recorded my data for this project on January 1st with my dad. Here is a map of where I drove. I began at the green X and ended at the red X. I started driving at 3:24 and drove for 30 minutes, ending at 3:54. I zeroed out my trip B odometer and drove for 16.8 miles. I took 15 velocity readings at 2-minute intervals. I then converted each 2-minute interval into seconds and converted the velocity in miles per hour to feet per second. I then added the converted data into numbers. I created a graph and plotted the points. I then connected the dots using straight lines. I then printed out a graph and calculated the left-hand sum. My end value was 15 for the 15 velocity readings that I took, and my base value was 120 for the 2-minute or 120-second intervals at which I took each reading. I did the same process to find my right-hand sum using n equals 15 and my base as 120. Using these sums, I was able to find the areas under the curve, which are significant of the distance which I traveled completing this experiment. I drove 16.8 miles. Converting this to feet, I get 88,704 feet. Comparing the three values that I found, while they are all significant of the distance which I traveled, they do vary. I believe this is because I chose to take readings at 120-second intervals, and over time, this large time gap allows for greater variability in data. I encountered more variables when taking my readings than I expected before starting the project, like trying not to get stopped at red lights, which I did successfully by staying in the right lane for most of the drive. Also, the speedometer in a car does not give a totally accurate reading of velocity. Velocity fluctuates more in city traffic than I ever realized. One conclusion that I drew is that over time, the actual distance traveled seems to differ more from the areas found by using left and right hand sums.